Hey guys, Mr. Middleton here. Today we're going to look at congruent figures notes. At the end of this lesson, you should be able to name congruent polygons. You should be able to use congruent statement to identify congruent parts. And you should be able to determine whether two figures are congruent based on certain information. Okay, so here's the big takeaway. Congruent polygons have congruent corresponding parts. Okay, when naming congruent polygons, always list the corresponding or matching angles in the same order. Okay, and that's how we're going to do it. We'll look at how to do that here in these upcoming examples. So here we're given two triangles. Notice all the markings that we have here. Remember that for a side, we can mark them with dashes to show that they're congruent. And for angles, we mark them with arcs. You'll also notice the different arcs here. R has one arc. That shows that it's congruent with F with one arc. T has an arc with the dash through it. That shows that it's congruent to angle D with the arc and the dash with it. Okay, the sides, you guys see that. So it says the figures that are congruent are, so we're going to name these figures. I'm going to say the triangle. I'm going to name this first triangle RST. Okay, just to keep it in alphabetical order. RST. So the triangles that are congruent are triangle RST, and is congruent to triangle. Okay. And now I did the first one in alphabetical order. That does not mean that I'm going to do the second or name the second triangle in alphabetical order. I want to make sure I use corresponding parts. So R is the angle with one arc. I want to make sure I name that with the angle with one arc. In this case, that's F. S is the angle with two arcs, so I have to use E, angle with two arcs, and then D. But you'll see that D is arc and not dash. Goes with T, arc and a dash. So we made sure our corresponding parts, our corresponding angles, are in the same spot. Okay, what this is called a congruence statement. Congruence statement just tells us what's congruent to what. Okay, and as we say, this triangle is congruent to this triangle, we are more in depth in saying angle R is congruent to angle F, angle D is congruent to angle T. Segment ST is congruent to segment ED. You'll see that all that has to be true if we match up the corresponding angles. Okay, so looking here, using that, it says, here's our congruent statement. Triangle TJD is congruent to triangle RCF. List all the congruent parts. Okay, so when we look at all the congruent parts is going to talk about angles and sides. Okay, so with this statement, I'm going to make markings similar to what we had in the previous problem so that I can see this a little bit easier. T goes with R. C goes with J. J here, C here. D goes with F. 1, 2, 3. 1, 2, 3. Okay, and so, and then I'm going to do the same sides as well. So TJ should be equal to RC. JD should be equal to CF. And then the remaining side, DT, should be congruent to RF. Okay, and so we can list all these out. I kind of just talked through them, but we'll list them all out. It says, because that's what it says. So angle J is congruent to angle C. I should have probably done this in order. Angle T is congruent to angle R. Angle D is congruent to angle F. Okay, and it's going to be a lot easier. You see how much you kind of keep this in your head. It's a lot easier to notice this as you make the markings on your diagram, and that is why I tend to do that a little bit more than listing them out. Okay, so with our sides, we have three pairs of congruent sides, right? So JT is going to be congruent to CR. JD is going to be congruent to CF. And DT, there we go, is going to be congruent to FR. Okay, all these listed, all these marked. Either way, it's the same information here. Okay, so second problem here, asking you about the same thing. Now, in the first problem, we were given a triangle. If you are visual and you're like, man, it was so much easier to have a triangle, nothing's stopping you from making your own triangle here. And usually when you make your triangle, it's a little bit easier because you can kind of not have it all jumbled. You can orient it the same way. And so it's a little bit easier to know BK, GW, KZ, WA, BZ, GA. Okay, and all the angles should be marked up the same as well because you put them where you want it to without a picture. Okay, and so our list is going to be the same, very similar. I'm not going to write it out, but you can. So I'll put that here, like pause to take a second to write out your angles and sides. Okay, just the same as we did up there. Okay. All right, notice how in the previous two examples, each triangle has 6 congruent parts. Okay, they're going to be 1, 2, 3 pairs of congruent angles, which we marked here, but I didn't write here. They're going to be 1, 2, 3 pairs of congruent sides. Again, we marked here, but I didn't write here. So in all these triangles, and even up here, we have 6 congruent parts. That's going to be important for us as we go through this chapter. Because this chapter, we're going to be talking about congruency in triangles. Okay. Here, we're looking at, well, this is definitely not a triangle, but it's a congruent figure. It says, if ACE SP is congruent to RWBDT, find the measures of each indicated angle. And so here, we're just testing that we understand what congruency means. Okay. If angle W, so we look at our naming convention here, W's here, it should be congruent to the angle in its same position. So W and C are in the same position. C's marked versus 132 degrees, so therefore we know that W is 132 degrees. Again, we know that because this congruent statement tells us that C is congruent to W. Angle D is not marked for us, but angle D, again, is in the same position as S. So if I know S, which I do, it's 88, then I know that D should be 88. And then angle B, where is angle B? It's the third one here. Okay. Should be the same as angle E. Do they tell us angle E? They do not. They did not tell us angle E. Okay, but we should know that it's going to be the same as angle E. And so what we can do to figure that out, what angle E is, since we're given the measures for everything else, is we can say how many sides are here. 1, 2, 3, 4, 5 sides. Okay, and so we can use our n minus 2, 5 minus 2 times 180, and say the sum should be 540 degrees. 540 is our sum, and all of our angles should add up to it. So the angles that we have, 90 plus 90, I'll just say 180, plus 88 plus 132, and I'll just call this angle E. Okay, so as we add all those things together, 180 plus 88 plus 132 gives us 400. And so we have 540 equals 400 plus E, subtract 400, and we find that E has to be 140 degrees. So since E is 140 degrees, we know it has to be the same as B because they are corresponding parts in congruent figures, so that means they are congruent. Okay. Next it says, are the triangles congruent? If so, give the congruent statement. So to prove these triangles are congruent, we have to show 6 parts congruent. Okay. From the start, we can say, well, AB is congruent to ED. And notice that we really didn't have to work for that. It's already told to us. And so when that happens, we call that given. As we go through these proofs, it's going to be very important that we have it organized enough so we can see what we're right, or what our statement and our reason is. This is kind of a go back to our second chapter when we do this with algebra. Okay. We should also see that BC is congruent to DC. Again, we didn't have to work for that. It was given to us. All right, we can see that angle A is congruent to angle E. Okay, again, it's just marked for us already. So that's given. Number 4, we can see that AC and CE are the same. Another given. And sometimes you don't really have to, I'm writing this each time so you guys know, but typically you can just write the givens and go on from there. Okay, so right now we have 1, 2, 3 sides, 1 angle, and I can also say that angle B is congruent to angle D, given. All right, so we have 5 parts. We need to prove that 6 parts are congruent right now because that's how we can tell that 2 triangles are congruent. And the only thing that we haven't marked is that angle C, or BCA, and ECD are congruent to each other. But we can say that those are congruent to each other because of vertical angles. So I want to make sure I mark that and say angle BCA is congruent to angle DCE because vertical angles are congruent. And I'll just say vertical angles. Okay. So our congruent statement then, we can call it and say triangle ABC is congruent to triangle EDC. Again, making sure that our congruent angles are in the same positions. All right. Number 3 here. Or sorry, the third angle theorem. Here's our third angle theorem. Kind of common sense, but here it goes. It says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angle is also congruent. Which makes sense because all triangles add up to 180 degrees. So if we have 2 numbers that are the same, the third number has to be the same as well. This last problem says, can you conclude that the triangles are congruent? Explain. So the given information is that angle J is congruent to angle M, and that angle K is congruent to angle N. Okay. And then if we look at this, we have vertical angles here, so you might be like, oh yeah, we have all the angles. But looking at our diagram, pay close attention to these markings. JL is 1 dash, LN is 2 dashes. Even though both of these are isosceles triangles, they don't seem to be congruent to each other or necessarily need to. So no, the corresponding sides, or what we would say the corresponding parts, would not be congruent to each other. Okay, so I'll say that out loud and not write it down. All right, last problem here. I'm going to just give all the given statements at the beginning. Okay, so the given information for us here is that angle Q is congruent to angle S, that QR is congruent to SR, that QP is congruent to SP, and that angle QPS or QPR, call it QPR, is congruent to angle SPR. Okay, and all that is just given information. We didn't have to work for any of that. It's all given to us. Now, we just talked about the third angle theorem. And so since we have 2 angles that are the same, we know this third angle has to be the same. So I'm going to name it and say angle QRP is congruent to angle SRP. Okay, and that's the third angle theorem. Third angle theorem. And so now I can mark that in my diagram because that is going to help me to notice when I have everything done. And then finally, I can say that PR is congruent to PR or RP. Yeah, PR, it's the same. And why can I say that PR is congruent to PR? Well, everything has to be congruent to itself, and that's also known as the reflexive property. Okay, and so now we've shown 6, 1, 2, 3, 4, 5, 6 parts congruent in the triangle. So each of the parts are congruent to its corresponding part. And so therefore, we can say triangle QPR is congruent to triangle SPR. Again, making sure that we're using corresponding parts in their same spot. And we can just say really definition of congruence here, because we've proven that everything is the same. All the corresponding parts are the same. This chapter will look at ways that we don't have to use 6 pieces in order to prove that triangles are congruent. But right now, we talked about how to write a congruent statement, how to go through proofs a little bit, and then how to figure out 2 figures are congruent based on certain information. All right, see ya.